All right, welcome everybody to your first video. We're going to start with 1.1, understanding points, lines, and planes. Simple vocabulary. Should be pretty easy. Remember, you can pause, rewind, fast forward, stop, do anything you like during the videos. Just take your time, take good notes, and we'll talk about it tomorrow. All right, so this is Mrs. Filiniak. I'm going to do the first few, and then the wonderful and talented Mrs. Kupasek will do some. We'll go back and forth here. We're going to start with just something simple, a point. Let's turn on our pen here so that I'm not moving stuff around. All right, a point is just simply a location. It has no size. It's represented with simply a dot and a capital letter. One thing to remember is that there's no dimension for a point. So things to remember, we need a capital letter. And I apologize for my handwriting. So capital letter. Okay. For instance, let's say we're talking about point P. It will look like that. My capital letter P. Boop. All right. The next thing that we're going to talk about is a line. A line is simply just an infinite set of points. It has no thickness, it has no width, and extends indefinitely in both directions, meaning it goes on forever. Okay? One thing to remember, and we're going to talk about this later, is that 2 points determine a line. So we want to name our line with a lowercase letter. Again, I'm sorry for my writing. Or 2 points. So for example, let's say I give you this line here. We got X there. We got Y there. Okay, so if I give you this line here, we could name it XY with a line above it, YX, or you can simply name it L. And the last thing we're going to talk about on this slide is a plane. A plane is a flat surface that extends indefinitely in all directions. Again, that word indefinitely means forever. It has no thickness. It's got 2 dimensions, and we're going to talk about this later, but one thing to remember is that 3 points determine a line. So we can name our plane with simply a script letter. I have awful handwriting on this thing. Or 3 points. This is our symbol for our plane. It's kind of like a parallelogram. Let's say you have something that looks like this. We got A there, B there, and C there. We could name this plane R, or you could name it plane ABC.
All right, so this is Ms. Kupasek, and I'm going to take over for the next 4 terms. The first term on this set would be collinear points, and collinear points are points that all lie on the same line. So if I drew a line, like Ms. Filiniak showed us before, I'm going to put points A, B, and C on that line. We can say that A, B, and C are collinear because they all sit on the same line. Collinear, like co-worker, working together, collinear on the same line. So what happens if we talk about non-collinear points? Well, non-collinear points are points that are not on the same line. So what if I took these points, A, B, and let's go ahead and throw C off of the line. Once I throw C off of the line and we list all of them, if I say A, B, and C, as the group, we would consider them to be non-collinear because there's one point that does not sit on that line. So that's non-collinear. One of them does not sit on that line. Same thing goes on with planes. If we talk about coplanar points, points all on the one plane, we can have what Ms. Filiniak showed us before, our plane drawn out. I'm going to go ahead and let's change it up here. Let's go an X, let's go a Y, and let's throw a Z on there. So I've got my 3 points, X, Y, and Z, and since they are all sitting in the same plane, we're going to end up getting points X, Y, and Z are considered to be coplanar. They are all on the same plane. Now what happens if I go ahead and do what we did before, and I take one of those points and I throw it off of my plane? Kick it out. Let's be mean to Z and throw it out here. There we go. So if I've got 3 points there, I've got X, Y, and Z. If one of those points does not sit on the same plane as the other two, then we would consider the group of them, X, Y, and Z, to be non-coplanar. Whoa, that's a big R. Non-coplanar. Good deal.
All right, first of all, I would like to say that clearly Ms. Kubasek is way more advanced at writing on an iPad. Her handwriting is so much better than mine. All right, continuing on. I'm going to finish up our definitions here. We got segments. Segments are just simply a part of a line that consists of 2 points and all of the points in between them. Okay, so part of a line here, let's say I've got my line. I'm going to put my point A and B on my line. Part of this line that consists of the segment is actually from A to B. A segment has endpoints. So we have the 2 endpoints. It's so hard to write in this thing.
I know.
2 endpoints. And in this case, our endpoints are A and B. So we could name this segment AB or BA.
Direction doesn't matter.
Direction does not matter. All right, and I was using this word already, endpoint. Endpoints are points at the end of a segment or the start of a ray. Ray we're going to talk about right here. And in this case, let's say I draw another segment. Let's call it segment XY. Simply look at the endpoints. Where does it start? Where does it finish? Well, it starts at X and ends at Y, or the other way around. Those are your endpoints. An array is just simply part of a line that starts at an endpoint and then extends forever in one direction. Think about like a ray of sunshine. It starts at the sun and goes down to the ground, right? This is your starting point right here. That's your endpoint. So let me draw a picture for you. There's my lovely ray. The endpoint is where the ray starts. So in this case, it starts here at point R. Let's say I draw it this way. It also starts at the end point here at point R. So in both cases, this is the ray RS.
Yeah.
All right, last term is just simply opposite rays. I like to think of this as, let's say you have 2 flashlights and then you put the 2 flashlights together, right? Where those 2 flashlights fuse together, that's where these rays actually are touching. These are 2 rays that have a common endpoint. So one thing to remember, common endpoint. And then you can use any other point in opposite direction. So let's take a look. I'm going to draw this picture here. LMN. We have 2 rays here, both stuck together with this point M. So our opposite rays we have are MN and ML.
So now that we've talked about those terms, we're going to actually apply them to what we call postulates. Postulates are statements that are accepted as true without proof in the mathematical world. So basically, they're common sense to us. So the first postulate we're going to talk about is the one that says, through any 2 points, there is exactly 1 line. So for example, if I were to put down 2 points and call them X and Y, try to figure out how many lines I can draw through those 2 points. Well, there's only 1. So, the first postulate, there's only 1 line that goes through exactly 2 points. Through any 3 non-collinear points, there's exactly 1 plane containing them. Key thing here, non-collinear points. That's basically getting us back to the definition of a plane. So, if I've got 3 non-collinear points, you can only put 1 plane through them. Next postulate, if 2 points lie in a plane, then the line containing those 2 points lies in that plane also. So it's kind of meshing together the first postulate with the second postulate. The last postulate on this section here is if two lines intersect, then they intersect in exactly 1 point. So no matter how many times you try to draw two lines out, if they are going to touch each other at their intersection point, which is, whoa,
Gotta put the pen on.
which is point E here, if they're going to intersect, two lines, they have to intersect in only exactly 1 point. Postulate, last one. If two planes intersect, then they intersect in exactly 1 line. As shown here, we've got two planes. We've got the green plane and the purple plane. And when they intersect each other, they're intersecting each other along this single line. Now, if you think about it, it's almost like a wall and your floor or your ceiling. The wall is one plane, the floor is another plane. When they intersect all along the corner. What do you call that? Molding, whatever. Whatever it is.
Where the wall touches the floor.
There you go. So it intersects in exactly 1 line.
All right, you guys, we're going to run some examples now. These are you're going to see on and off throughout your homework, on your quizzes, on your tests. So I'm going to run through the first one with you, part A in example 1. Then I'm going to have you finish B, C, and D. So you'll pause me and finish, and when you come back, you'll be able to see the answers. So in example 1, they want you to use this figure here to name the following. I would like for you in part A to name 3 collinear points. The first thing you have to do is remember, what does the word collinear mean? Collinear, remember co-worker, that's what Ms. Kubasek said. Linear, on the same line. So we need 3 points on the same line. And if you look at the picture, the 3 obvious points that are on the same line are A, B, and C. So you would just simply write A, B, and C. So now for B, C, and D, I would like for you to try these. So you're going to pause the video now, and then when you hit play again, you should be able to see your answers. Yeah.
Yeah.
All right, you guys. So we have our answers up here. We're going to run through them real quick, and then we'll go on to the next example. So 4 coplanar points, as you can see, all of these points are actually in the plane. So you could have had something like A, B, C, or D, but E, don't forget, E is also in the plane. So if you had E replacing one of the other letters, that's okay. In C, a plane containing the point A, don't forget we can name it with a script letter, or 3 points that are non-collinear. So in this case, we picked A, B, and D. However, if you would have picked E, C, B, or D, C, B, or any other combination, it would have been okay. The only combination that's not okay is A, B, C. The reason why? You can't name a plane with 3 points that are in the same line. So remember, they have to be 3 non-collinear points.
All right, so in example 2, what we're going to do is we're going to test out your drawing skills a little bit. We've got 4 problems here, and I'll run through the first one with you, part A, and I'll give you some time then to go through B, C, and D on your own, and then we'll check them together. So the first one says we're going to go ahead and draw a line containing points S and T. So I know that I have to work with 2 points, and so we're going to draw 1 point S and another point T. Do they have to be in that order? Could I have drawn T first and S second? Sure, it doesn't matter. Do I have to draw them this way? You could draw them anywhere in that space. It doesn't matter. So it has to have a line that contains both of those points. So we're going to go ahead and we're going to connect those two with the straightest possible line you could draw. And that is our line containing points, points S and T.
It's beautiful.
Next, you're going to try B, C, and D on your own. Pause the video here, and when you start it back up, we'll have some answers written down for you. So let's go ahead and take a look at what you've got compared to what I have written down. For B, a pair of opposite rays that both contain point R. This is what Ms. Feliniak was talking about. If you have ray RW and ray RQ, they both share the point R, and they make a line when you put them together. So those are opposite rays. Anytime you're working with those opposite rays, the point that is contained by both rays has to be in the middle. The next one, hopefully you saw, sorry I had to draw out the ray on top. It's ray KM. So ray KM, when you name a ray, you always start off with the endpoint. So when I'm drawing it, I wanted to start off with the point K, because that's the endpoint, and it has to travel through the point M. So either you could have drawn it with KM in this direction, or you could have drawn it with KM in this direction. You cannot switch these two letters. It must start at K. The last example here is line segment PQ. So when you have a line segment, you have two endpoints. You have P and Q as your endpoints. So you could either draw it with P starting first and Q, or you could have started off with Q and then P, because there is no need for direction on that like a ray. All right, here's the last one. It's a little bit of a challenge one. So what we're going to do is we're going to have you try to sketch out 3 coplanar lines that intersect in 3 different points. I want you to try that out on your own. Pause the video here, and then when you come back, hopefully we'll have something that looks like what you ended up getting. So hopefully you ended up having a drawing that looks somewhat like this. We have sketched out our blue box representing our plane, and 3 coplanar lines. So they all sat inside of our plane, and they're intersecting at 3 different points. So this first line, our second one, and our third one, they intersect at the 3 different points. So a little bit of a tricky problem, but hopefully you ended up getting it.
Okay, you guys, so that does it for 1-1. I'm hoping that you're going to enjoy this type of learning method. It'll take some getting used to, but we'll get there, you guys. We'll get there. One thing that I want you to remember, something that you have to do, is you have to go through and do your whisk. Remember, this is where did you watch your video? Summarize your video. So summary. And we're looking for 1 question. If you have more, that's great. But this is the first thing that we're going to do tomorrow. So be prepared to have this conversation. All right. Until next time, you guys, have a great time, and we'll see you tomorrow in class.